Okay, let's continue. So where are we? So in open, okay. So the third argument is basically how many bytes you want to read, because we are reading integers, right? So how many bytes for one integer? So it's
four.
4, right? But what if I don't know that? What if I don't want to hard code it? You can use size of, right? So size of int is just 4, but we just don't want hard code it. We just use this. And like I want to read the first 10 integers. Then we basically read the first 40 bytes. Okay? So that's how the system called read is used here. And after we read, we can try to test if the integers are in the buffer, right? So we can say, because it's 10 integers, so I equals 0, sorry, I equals 0, then we do a for loop to see if they are already there, okay? Let's try to printf integer. So it's the ith element in the array. Okay, does it work? It's kind of tricky, but anyone has. So if I ask this question, probably the answer is no. Then why not?
So read needs to equal something.
Oh, that's just the return value. It's fine if you kind of like a return code. Okay, that's the point exactly. Right. So buffer. Yeah. So just now I said it would not work, but in the modern Linux system, probably it will work, but sometimes it will not, particularly when I is very huge. So the issue, he's correct. So what's your name? Okay, Zach. So he's right. Because buffer here is just a pointer. It doesn't. It's just a. Right. It hasn't pointed anywhere yet. So I think in Java, it's if you like have an object, you don't initialize it. It's just kind of. Right.
So as soon as you start writing, you just write whatever that pointer happens to be, which may or may not be good.
Right, that's very bad, and will probably lead you to another seg fault. So how to resolve this issue?
You can initialize somehow.
How? The best way to initialize it.
Say equal to 0x 0, 0, 0, 0.
Like an array, right?
I was going to say
That's very good.
See, for instance, depending on what you're trying to do on the size of your snappers, if you wanted to do it on the stack, you could do it on memory. That's probably not recommended.
No, we just want to do that on a heap.
So then you want to use malloc.
Exactly. So we use malloc. So anyone familiar with this? So this essentially means memory allocation. It's dynamic allocation. Again, you can take a look at the menu. So it's also in the C library file. We've already included it. So it just allocates size, some bytes, and return a pointer to the allocated memory. However, the memory is not initialized. So you've just called malloc, and you just try to access some of the element in that chunk of memory. You will not get seg fault. You will not get error. You are fine, but they are not guaranteed to be 0. So every time when you try to use malloc, then you should try to initialize it, meaning you should make them all 0. You should use another function called memset, but I think that's currently we don't cover that yet. So the key idea is that malloc is a very important function, and we'll talk more about it in the second chapter of this course for the virtual memory management. And Gerard will talk more about the malloc. And I think if you take course of CS537-2 you also get a lot of hear a lot about malloc. Okay, so here it's just you can treat it as a function that allocate a chunk of memory that is on the heap, and it's dynamic allocation. It's not the same with you initialize an array. If you initialize an array, then it's actually stored on the stack. It's static. But here, the memory allocation is dynamic. For like, what is stack, what is heap? Again, you can wait to the second part of this course. You'll get a very detailed exploration on the memory virtualization. Yeah. Okay. So we just use malloc to to allocate some memory. So because we're just reading the 10 integers, right? And we just allocate this many memory, like 40 bytes. As a good habit, you probably want to cast it, but if you don't, that's totally fine. But it's kind of like convention. Every time we try to malloc something, we always cast it to the corresponding type. Okay, so this casting is optional, but as a convention, we just do that. Okay, now we are ready to go. So now the buff is pointing to a chunk of chunk of memory, which is already allocated, and you can do anything you want in this chunk of memory. Okay, now everything should work, hopefully. So, oh, okay. Now let's compile it first. Okay, so there's some warning. Yeah, I think read is. Yeah, I think I forgot to include this. Yeah, the function, the Unix standard functions. Okay. So now it compiles and then open. Okay. So basically, we have like the first 10 integers that is read from the sample in. Okay. Why is some numbers are very small, some are huge? That's totally because of because how it's the input file is formatted. Okay, now I think we need to spend some time on how what does the sample in, the data structure, or what does each number mean in this input file, the sample in. Okay, so I think in the specification, we mentioned that the file begins with a header. It's just a single integer, which is R, and contains a number of records in the file. So it corresponds to R, which is the first integer, which is 10. So here it means it tells us there are 10 records in this input. Okay, and then after the header, the file contains variable-sized records. Each record can be different size, and it is structured as follows. Okay, the first one is the index. It just ranges from 0 to so in here is 0 from 9. Okay, so for the first record, the index is 0. That's consistent. Okay, and then the data size. Okay, the second 4 bytes are an unsigned integer indicating the size n. Means there are n data in this record. Okay, so here that is 4. It means there are 4 data in the first record, followed by these 4 numbers, which is just the data of the first record. Make sense? And then we come to index number 1, the next record. Okay, this is its index. And then 16, it means in this record we have 16 data for this record, and so on and so forth. So this is basically the format of the input for this project. So as long as you understand how it's formatted, I think it's not hard for you to use a data structure to store them. Okay, so here I just skip this part. And if you can look at the, I think you can use dump var. This is given in the specification. This is essentially dumping or output the records or output to the in a human readable manner. So because the original sample in, sample out are all binary files, they are not human readable, and you can run this dump var to get a human readable output. So we can see here it's a bunch of, there are a lot of hints in both dump var and also another one, gen var. Gen var is just to generate variables, and the output is essentially the input for your var sort. And dump var takes your output from your var sort as an input, and then output a human readable text. Does that make sense? Okay, so there are a lot of hints and actually a lot of snippet you can directly use from both gen var and read var. So for the first chunk is just reading the options, the command options. I think this is kind of tedious. You have to figure out yourself. You just spend some time, but there's just you can just treat it as an example and mimic how it does, and then writing your own version for this. So I will just skip that. So here you see that just open the input file. Yeah, it's essentially the same with what I did just now, but it just uses read-only because for this part we don't need to modify the file, so we just take the read-only. And here we just make sure that the file descriptor is non-negative, because if it's negative, then something's wrong, right? Just because the file does not exist. And here is the data structure. Okay, this is just the R, the record, the number of records. And here we go through a while loop to read each record, right? And each record will just use the system call read. And then we take this many bytes. So on and so forth. And here we just output the data to a human readable text. Okay, so this is basically what it does. So let's just try to run it. Before running, we need to compile it. Okay, and sample in, I think it's, okay, I think I need a -I as an option. Okay, here we go. So this is just a human readable version of the sample in. So number of records 10, correct. So there should be 10 records here from index 0 to 9. And data ins means number of data in this record, which is 4, right? This 4 data. And index 1 has got 16, and we got 16 data, so on and so forth. So the dump var is a very useful tool to debug, basically. So you can, because the output is binary, you can hardly see what's going on. But when you try to run dump R, you can get a sense of what might go wrong. Similarly, genvar is to generate the input. So similar thing there. And I think in genvar there are more options, like how many records you want to produce, and how many, and some random seeds, something like that. I'll leave you to explore that. But here it's just a very simple demonstration to how to use the dump bar. So far, any questions?
Can you just go back to your other code for a second?
You mean
Where you like just showed the
Oh,
output like
the demonstrator?
Yeah.
Okay, like the OP?
Yeah.
So I think this,
Yeah, but I don't have to stick around.
that's fine.
Maybe I'll see questions.
So if nothing else, I think that's basically the. I think the key issue here is the system calls, the open, read, and write. Okay, yeah, sure. I can show you another. Yeah, because just now I only showed you the read, right? Okay, now let's do similar thing to write. Okay, let's try to create another file. I'll just do here. Just close it first. Now I'll just read again, open again, but this time we'll just call like demo out, for instance. Okay, now this time we just use, because this file does not exist, so we need to create first, and then we make sure that it's read or write. Probably just write only is fine, but in case. Okay. Again, we should like make sure that nothing fails using the search. Sure, you can use if statement, but yeah, assert is also fine. Excuse me. Now let's try to write what we stored in buffer to a new file. Okay, so basically we just call. Oh, by the way, just now you asked. The read probably should return something, right? So actually this return code, again, you can look at the man page of read. So basically it returns, what it returns? Okay, so I'm not sure. Okay, so return value on success, the number of bytes read is returned. So basically just an integer. That should be, okay. So if it's successful, the returned value from read should be exactly the same with count, right? Otherwise something goes wrong. So as a sanity check, you can just make sure that after you read, you do assert rc equal to this guy, right? Otherwise something's wrong. Okay. So I think write is similar. So again, this time you should not read again. So write is the first argument is also again the file descriptor, and then you take the buffer, and then how many bytes you want to write. So I think it's almost the same with read. Okay, I think that's it. Let's compile it. Okay, now we have a demo out. Okay, so if you want to cat it, that's just a bunch of garbage because they are binary files. I think if you have done the worksheet, it mentioned we can use a tool called XXD, right? This is essentially just to dump the binary file into hexadecimal, you can try here. Dump out. Still looks like garbage, but actually you can have a send. You can actually have some. It has some traits in it. So, as just now I mentioned, each integer is 4 bytes, right? Because here they are in hexadecimal, so 4 bit of hex is essentially 1 byte, right? So here it's just 1 byte, and here, okay, sorry. The four bits of hex should be 2 bytes. So here it should be 2 bytes. And so 4 bytes is this. So this 4 bytes represent 1 integer. So as just now we output it, the first integer is 10, right? So this 4 bytes represent 10. Why is 10? So you can see A here. A in the hex is 10. So for instance, here, this guy is 0, right? Corresponds to this 0. And this is 4, which is 4. And here, this string actually corresponds to this number in hex. But the order is slightly different because of the endianness. So I think because this is in the worksheet, so I think you should do some research if you don't know what endian is, okay? But it's actually very simple. So just as a side note to tell you that. Okay, but anyway, the best way to inspect your output or input is use the dump bar, right? Because that produces the human readable text. But here it's still kind of fuzzy, but it's just a kind of a way to show you how the binary files are corresponded with the string of integers. Okay, so I think that's basically it for the read and write part of the project 1A. Any questions so far? Okay, probably we need to take like 5 minutes break and then we'll jump into 1B. Okay.